Hello, everyone. Today we're continuing our discussion of similar triangles, and our methods for proving triangles similar is AA similarity, side angle side similarity, where we have to prove the two sides are proportional, and then side 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 similarity. So, when we're looking at this problem, we know that WR is parallel to VB. So if I know those two lines are parallel, that tells me, and there's actually a couple ways I could easily do this. I know that angle R is congruent to angle V, and I know that angle W is congruent to angle B. And why I know those is because when I have parallel lines, alternate interior angles are congruent. Now, if I wanted to, instead of doing one of those, I could have done one pair of those and then used my vertical angles. But now that I know that, I have enough to say these two triangles are similar by angle-angle similarity. So triangle WSR is similar to triangle BSV, and the reason is angle-angle similarity. Now, to do the rest of the problem, they told me that SB is 10, WS is 15, SV is 20, and RS is what I'm looking for. So if you look at how my triangles are similar, I kind of have to spin it. So it really goes SB over SW equals SV over SR. That's how they're proportional because of corresponding parts. So then I'm just going to do 10 over 15 equals 20 over x. Cross multiply, 10x equals 300, x equals 30. So number 2, I want you to pause and I want you to see if you can prove these two triangles similar. Okay, so in this, I stated that angle AEB is right because definition of perpendicular. Angle DAB is right because in a rectangle, all angles are right. Therefore, those two angles are congruent. All right angles are congruent. Angle B is congruent to itself, reflexive. So these two triangles are similar. BAD is similar to BEA by angle-angle similarity. Okay, so now another new theorem. It's called the side splitter theorem. If a line is parallel to one side of a triangle and it intersects the other two sides, then it divides those sides proportionally. So in this example, if BD is parallel to AE, then CB to BA is equal to CD to DE. So that means for number 1, 4 is to 6, as y is to 9. We cross multiply, 36 equals 6y, divide 6 equals y. And the reason why that is it gives us similar triangles and parts of the triangles are similar. So now in number 2, find DB if AE is x, AD is 1, DB is x, and EC is x plus 2. And I know that DE is parallel to BC. So that's x over x plus 2 is equal to 1 over x. So I cross multiply and I get x squared equals x plus 2. So that's x squared minus x minus 2 equals 0. So that's quadratic. So I want to solve that. I'm going to try to factor, which I can. It's x minus 2 times x plus 1. because negative 2 times 1 equals negative 2. Negative 2 plus 1 equals negative 1. So x minus 2 equals 0, or x plus 1 equals 0. X equals 2, or x equals negative 1. I'm going to reject the negative 1 because of length. I can't have part of my triangle be negative 1. So therefore dB is 2. So I want you to pause and I want you to try number 3. Okay, so 3 is different because even though they're parallel and it is the side splitter, DE and BC are not the sides being split. So in this case, I have to use the triangles. So I'm going to say 6 is to this whole side, which is 6 plus x minus 1, is equal to x over 6. So that's 6 over x plus 5 is equal to x over 6. Cross multiply, 36 equals x squared plus 5x. It's quadratic, so it has to equal 0. So that means x squared plus 5x minus 36 equals 0. Factors of negative 36 that add to be 5 are x plus 9 and x minus 4 equals 0. So x plus 9 equals 0. X minus 4 equals 0. X equals negative 9. X equals 4. I'm going to reject the negative 9. And they asked me to find ED. So ED is 4. So that's the end of our video. If you have any questions, please ask me in class.